Okay, my problem was problem 11 from problem set 1, and it's a story problem, and what it says is a landfill was monitored to verify that toxic compounds were not leaching into the local water supply. So wells were drilled at 21 locations and were monitored over a year, and pollutants were only observed at the sites that I have in red here. So 8, 11, 12, and 13 had contaminated water in them. So part A asks, what does the test indicate to you? So simply looking at the diagram, you can tell that what the test indicates is the barrier wall isn't doing its job. It's not preventing the toxic chemicals from the landfill. It's not preventing them from getting into the wells. So majority of the wells along the barrier wall still have contaminated water in them. So part B then asks, monitoring all the sites each month is very expensive. So suggest a strategy to use composite samples, taking water from more than one well at a time to reduce the cost of routine monitoring. So my strategy was to do 3 separate composite samples and take a composite from wells 1 through 7, 15 through 17, and then 18 through 21. So this would be beneficial and cheaper because you're only analyzing 3 samples as opposed to analyzing all the samples individually. So it's going to save time and money. You don't want to do a composite sample of the wells along the barrier wall though, because they are known to have toxins in them. So you want to do them individually so you know from what well the water is contaminated and where the water is coming from. But since these wells don't normally or haven't had toxin found in them, you can do a composite sample of them, which is just taking water from the individual wells and clumping them all into one big sample. So that leads to my part of the question, which says, how will your plan affect the minimum detectable level for pollutants at a particular site? So let's take my composite sample of wells 15 through 17 here. So if we were to do individual samples of wells 15, 16, and 17, let's say we would use 30 milliliters for each well. So if we were to analyze each 30 milliliters from each well, and well 15 was contaminated. So we would find a signal, and I'm just using this signal randomly, it doesn't really mean anything, but a signal of 1.5, let's say we know the water is contaminated. So if we were to find 30 milliliters of contaminated water, the signal would be 1.5. So we analyze these individually, and that's what we come up with. But a composite sample is taking 10 milliliters from each well and combining them all to make one big composite sample of 30 milliliters of water. So instead of having all 30 milliliters of water be contaminated like we would in well 15, only 10 milliliters of the composite sample is going to be contaminated. So we're going to have our signal diluted by 3 times. So it's going to be not as strong of a signal, so it's going to be a 0.5 signal to be contaminated because you have 20 milliliters of clean water and only 10 milliliters of the contaminated water, as opposed to if you were to do them individually, you would find all 30 milliliters of well 15 water contaminated. So you can tell that from 1.5 to 0.5, the signal is being reduced because it's being diluted. So for our answer, how will your plan affect the minimum detectable level? It would reduce the minimum detectable level because, again, the composite sample is going to be diluted because of the clean water that's being taken from well 16 and well 17. So our minimum detectable level is going to